this computer. Now we're recording. Awesome. Okay, so if you have questions, please submit them to the Q&A. Do us a favor, and if you have questions for me, like when's the next session, or can I get an extra link for another person, like put those in the chat. But if it's a question about the moon, put them in the Q&A so it's easy for us to keep track of where they're all going. Yeah, at this point, I'm just going to hand it over and let's start learning about the moon.
All right, sounds good. So I have just a few slides to tell you all a little bit about what I do. And then hopefully we'll have lots and lots of time for questions, which are always the best part. So I'm going to go ahead and share my screen. All righty, so I'm going to assume everyone can see and hear me, but if you don't, just give me a shout. And I will stop and I will fix my computer.
All good.
But yeah, thanks, Sarah. So thanks again for having me, and thanks everyone at home and or in school for dialing in. Really happy to get to talk to all of you today. So my name's Parvathy, as Sarah mentioned, and I am a planetary scientist. So here's a picture of me being a planetary scientist. These are my two assistants who right now are in the other room because, as you can see, they generally don't do a very good job of assisting me. So this is Smokey, this is Apple Dumpling, and as you might have noticed, they're also both cats. But they try and help me out sometimes. And what does a planetary scientist do? So as you might guess, a planetary scientist is a kind of scientist who studies planets, but not only planets. Planetary scientists also study the moon, the moons of other planets, and all of these other weird and wonderful worlds in our solar system. So I spend a lot of my time studying the moon. So you're going to hear a lot about the moon today, but I am happy to talk about some of the other planets as well, if anyone has any questions about those. And one question I get a lot is what my favorite planet is. So I figured I would preemptively answer that one in advance before someone asks it. My favorite planet, of course, is planet Earth. This is a picture taken right here on planet Earth. This was a few months ago when it was still green outside. The trees are kind of bare now, but this is the Middle Patuxent River, which is about a 10-minute walk or drive away from where I live. I live and work in Columbia, Maryland, not too far from this river. And I love planet Earth because, as you can see from this picture, it has so many of all of the best things out there in the solar system. It has air and running water and trees, and what more could you want? So there really is no planet like home. And not too far from that river and from my house where I'm dialing in today. Well, it's actually an apartment, but so up on the 4th floor, in case you're wondering where exactly I am. So about 10 minutes from where I live is my office, which is in this building right here. So this is the building that I work in at the Applied Physics Lab, which we call APL for short. So A for applied, P for physics, L for lab. And this is the space building at APL. And in fact, this arrow right here is pointing to the window of my office. And so usually every morning I get up and I drive to my office and I climb the elevators or climb the stairs or take the elevator to the 2nd floor where my office is. And so if you're ever in town, come and stand outside. And if you wave really hard, my office mate Neil might see you and ask me if I know anything about that, and I will come down and say hi. So at APL, there are a whole bunch of folks who help make the work we do possible. So among other things, we have a whole bunch of planetary scientists at APL. So I thought I'd tell you a little bit about what planetary scientists in general do. So I think one of the nicest things about planetary science and being a planetary scientist is that there are lots of different ways to be a planetary scientist, depending on what you like to spend your days doing. So these are some colleagues of mine, and this is me a few years ago when I was in grad school. And here they are doing planetary science in their own different ways. So for instance, some planetary scientists spend a lot of their time thinking about how to build spacecraft, which are little robots like this one that fly through space to other worlds and send back messages telling us what those worlds are like. So some planetary scientists spend a lot of their time thinking about how to build spacecraft and then talking to the spacecraft once they're out in space. So for instance, this is my friend and colleague Zibby Turtle, and she is the lead scientist on the team that is working on building this robot, which is, I think it's actually a little bit larger in real life. So this is just a model of a spacecraft called Dragonfly, which quite a few years from now, when it's all built and ready to go, is going to leave planet Earth and head all the way to Titan, which is one of the moons of Saturn, and tell us all about what it sees there. So planetary scientists like Zibby spend a lot of their time working with spacecraft. There are also planetary scientists like my other friend and colleague, Karen Cahill here, who do lab experiments. And so here, Karen is in her lab, which is just across the hall from my office. And I'm not entirely sure what she's doing in this photo, but I think what she's doing, which is something that she does quite often, which is to look at space rocks, meteorites, and what those space rocks can tell us about other worlds out there in the solar system. So sometimes we go to other worlds to see them up close, but other times there are little chunks of rock that break off other worlds and travel the other way, all the way back to Earth, where they sometimes fall down to us, where we can take those rocks into our labs and study them up close and look at what they're made of, how old they are, how they reflect light, and all kinds of other interesting things. Then there are some planetary scientists like me who spend a lot of their time building and using computer models to try and understand the solar system. So some of you might have some experience building computer models, but basically, when people ask me what a computer model is, it's basically taking a few different ingredients. So you need a little bit of imagination, a bit of math, a bit of physics, and then a bit of computer programming. And you put those together and use that as a way to ask and answer questions about various strange situations across the solar system. So I spend a lot of time doing computer models. And then last but not least, planetary scientists also spend a lot of time exploring our own planet. So I don't know most of the people in this photo, but in the middle there is yet another friend and colleague, Nancy Chabot. And in this picture, Nancy is with a whole team of other people, and they are exploring Antarctica, which is one of the strangest and one of those strange and alien environments that exist on our own planet. So Antarctica, for instance, is a very good place to go if you want to study what a very cold solar system world might be like, and what kind of things shape a world like that. And similarly, there are planetary scientists who might go out to the desert or to really cold and dry valleys in Antarctica that might remind you of the environment of planets like Mars, for instance. And so actually, in this particular photo, this team of planetary scientists is out there on the ice looking for space rocks, like the one that Karen looks at in her lab. But planetary scientists sometimes travel to these strange environments on our planet to do other kinds of experiments and learn about other kinds of things as well. So those are some of the few ways or rather, those are a few of the many ways in which one can be a planetary scientist. And as I mentioned, I spend a lot of my time studying the moon. And I'm also part of a team of people supporting this spacecraft that you can see here called LRO. So LRO is the Lunar Reconnaissance Orbiter. It's a spacecraft that we sent to the moon in 2010. And since then, it's been orbiting the moon round and round, looking down at the surface and learning about the surface of the moon using 7 different kinds of science instruments. So when we talk about science instruments, we usually mean cameras or telescopes that look at the moon in different ways and tell us what they see. And so if I play this little video here, this is a close-up view of the LRO spacecraft. And so this is just an animation. So this is a cartoon that shows you where some of the cameras and telescopes on LRO are, where they're pointing. They're usually pointing down towards the surface, so not always. So you can see some of those attachments there. Then here's the big solar panel, which soaks up solar energy and provides power to keep the spacecraft running. And then as the spacecraft passes overhead above the moon, and the cameras and telescopes collect all of this information, they use this big dish, which is the communication dish, to beam all of that information back to planet Earth, which you will see appearing just above the horizon in this little cartoon. So that is LRO, which is my personal favorite spacecraft. And so LRO is up there right now as we speak, getting to know more about what the moon has to tell us. And so I wanted to take a little bit of time to tell you a little bit of what we know about the moon's story. And so let's spend a few slides imagining the moon's story. So based on information that we have from looking at moon rocks and from listening to all of the stories that LRO sends back to Earth, here's how we think the moon formed. So this is a cartoon version of that. So we think that long ago, at the very beginning, when Earth formed, it was a smaller planet than it is now, and it was kind of lonely. It didn't always have a moon. But very soon after the Earth formed, the solar system was a much more violent place than it is today. So there were all of these chunks of rock and ice left over from forming the planets that were whizzing around the solar system, and every now and then they would collide. And so the planet that would later become Earth as we know it was sitting out there in space when we think another object, a little bit smaller but still quite big, collided with it. There was a lot of energy generated during that collision, and that energy heated up the rocks that formed both of those objects, and it sent a lot of pieces of rock flying out into space. And then over a pretty short length of time, geologically speaking, some of that rock that was thrown up into space around the Earth came together to form the moon. And that's how all of these billions of years later, we have the planet that we know today. We have planet Earth here and the moon up in orbit around it. And I have another video here, which tells you a little bit of the story between what happened between this time and this time. So this is a video that was made by some friends of ours at NASA down the road from where I work. And it shows you a little bit of the early evolution of the moon. So when the moon initially formed, we think it was really hot, and that's why it looks like this big glowing chunk of rock in this video, because of all of that energy from that collision that created the moon and put it out there among Earth. And so just like the collision that formed the moon, at around this same time, shortly after the moon formed and after the surfaces had cooled, the moon continued to be hit by all of these chunks of rock and ice. And this video is speeded up quite a bit, so this might not have happened quite as fast. They didn't all come in at once. But over time, the moon continued to be bombarded by all of these chunks of rock and ice that were flying around the solar system. And they left in the surface of the moon some of those craters, some of those holes in the ground that you can see even today when you look up at the moon. At this time, the inside of the moon was still really hot, even though the surface had cooled. And that led to volcanoes, volcanic eruptions on the surface of the moon. So you can see all of these lava fields that were erupting for several billions of years before they cooled and they formed this dark colored rock that you can still see if you look up at the moon. So if you look up at the moon tonight or anytime, you'll see some of these dark hardened lava patches. And so throughout this time, even after the volcanoes had erupted and then cooled into rock, the moon continued to be hit by all of these leftover rocks. And in fact, even today, the moon is still hit by some tiny pieces of rock and dust that are still left over and come from elsewhere in the solar system. And those continue to form craters even today. But that is what gave us the lovely moon that we see today, and the moon that LRO has been exploring from high above for the last 10 years. And so what does the moon look like through LRO's eyes? So I mentioned that LRO, the Lunar Reconnaissance Orbiter, has 7 different kinds of telescopes and cameras. And so that's almost like having 7 different kinds of eyes or 7 different kinds of glasses that you can look through. So for instance, if you were sitting up in space on LRO and looking down at the moon through the Lunar Reconnaissance Orbiter camera, you would see before your eyes a scene that looked not quite, but something like this. So this is what the South Pole of the moon, which is the actual South Pole is right here in the center of this image. And so this is the South Polar region. But here's what it would look like to your very own eyes as you look at that surface in visible light. And so you'll see that for the most part, it's this rugged grayish world with these shadows that come and go as the day passes by. And so if you were up above the surface of the moon, you would see a scene like this, and the shadows would be coming, going, and changing over time. Now, if you switch out your regular glasses, pair of infrared glasses, you would see a scene that looks something like this. And so, so what do I mean by infrared glasses? So one of the telescopes on LRO looks at the moon and sees not the light that we see with our regular eyes, but it sees how hot or cold the surface is. So this is almost like if you were sitting on LRO, on the spacecraft with your eyes closed, and you stretch out a hand, you could feel as the spacecraft passes over the moon, how hot or cold the surface is. And you can convert that into a map that looks something like this. So the colors on this map are not the colors of the rocks, but they tell you how hot or cold the rocks are. And so you can see that in the places where it's dark purple on this map, those are parts of the moon that are very, very cold. In fact, those are some of the coldest places in the whole solar system. And then there are other parts of the moon that are not so cold, and some of them are really quite nice temperature-wise. You can also see through another one of the cameras on LRO how starlight is reflected. So when LRO is out there above the moon, some parts of the moon are lit up by sunlight. So the sun is our closest star, but out there in space, you have all of those other stars in the Milky Way. And every one of those stars is like a little flashlight shining down on the surface of the moon. And so if you look at LRO, if LRO looks at the moon through a camera that's sensitive to that starlight, it can see how much starlight is reflected from the lunar surface. So this is like, this is almost like looking at the moon in the dark with thousands of little flashlights, which are all of the stars in the sky. And you'd see a view that looks something like this, where some parts look dark and some parts look brighter. And that tells you information about how fluffy the surface is, what it's made of, and other kinds of interesting things. So there are lots of different ways to look at the moon. And that lets us ask all kinds of questions about the moon. So for instance, one of the things that I spend a lot of my time thinking about is water on the moon. So on Earth, it's all around us. It's in the atmosphere, it's in the clouds, it's in the rivers and the oceans. Now, when you look up at the moon, you might not see any rivers or oceans. And in fact, the moon doesn't have rivers or oceans or clouds like we do on Earth. But one of the things that we discovered sometime over the last 20 to 30 years is that in some of those cold, shadowy craters near the surface of the moon, which you might remember from the last slide, in some of these cold, dark craters, we have some information from LRO and other spacecraft and telescopes, even on Earth, that there is some water in those craters, and we think that it's in the form of ice. So some of that ice might exist near the south pole of the moon, which you see today, and this is animated so you can see all of those swirling shadows coming and going. And of course, it's very different from the south pole of Earth, where we have water in icebergs, we have water in the oceans, the atmosphere, and of course we have penguins. We don't have many of those things on the south, near the south pole of the moon, but one thing that the poles of these two neighbors share is that there is ice in some form on both of these solar system worlds. And so one of the most interesting questions or at least I think it's one of the most interesting questions I spend my time studying, is how and when water got to the moon. So we have all kinds of ideas about how that might have happened. And I spend a lot of my time trying to figure out, how some of these scenarios would work, and how we could tell where that water came from. But these are some of the ideas. So one idea is that perhaps the water on the moon got there from comets that collided with the moon a long time ago, or maybe from some of those volcanic eruptions that we saw a few slides ago. When volcanoes erupt, they can bring not just lava to the surface, they can sometimes also bring steam and water that's dissolved in the lavas as they come up. And for instance, in this picture is a recent photo of a comet that flew by the Earth a few years ago. So this was Comet Pan-STARRS. So comets are mostly made of ice. In this particular case, the moon, but you can see them both in the sky. And so this illustrates what might have happened in the distant past in a different way. We think that a few millions or hundreds of millions of years ago, some comets like this one might have actually collided with the moon. And then some of the ice in those comets might have been left behind on the moon. So that's one idea for how the moon got its water, from comets or asteroids, or maybe from some of the volcanoes. And you can see those dark patches of volcanic rocks on the surface of the moon, even today. Another idea is that maybe water gets to the moon from tiny meteorites, so tiny versions of those comets and asteroids, or even from the sun. So in this video here, you can see that if you were to peer really closely at the surface, and this is a cartoon, so this isn't a real video, but it's an artist's imagination of what you might see. If you peered really closely at the moon, you would see that the surface of the moon is constantly being hit by all of these tiny pieces of rock. And some of those tiny pieces of rock might provide enough energy to create water from some of the rocks that make up the moon. And in fact, water can also reach the moon from the sun in quite a strange and unusual way. You can have, so water, as some of you might know, and if you don't know, you'll learn this pretty soon, but water is made up of two parts hydrogen and one part oxygen. And so one part of that, the hydrogen part, can come from the sun. So our sun is sort of this fiery star in the middle of our solar system, and it sends out not just light everywhere into space. The sun also sends out this very fast moving stream of hydrogen that touches everything in the solar system, even our own upper atmosphere. And so some of that hydrogen from the sun can reach the moon, where it can join together with oxygen in lunar rocks to form water, which is made up of those two things, of hydrogen and oxygen. So there are all kinds of interesting ideas about how the moon could get its water. And the best part is that there are still lots of things that we don't know. So I think, as a planetary scientist, for me at least, I like questions better than answers. So there are lots of things that we still don't know the answers to. We're not quite sure how much water there is on the moon, but we know there's some. We're not sure what else might be there besides water. We know there's some ice on the surface of the moon, but we're not sure whether there might be more ice buried below the surface. And then the reason we want to know the answers to some of those questions is to try and figure out the story of how the solar system and our solar system neighborhood came to be the way they are. And so I use physics, math, a little bit of imagination, and my computer to try and work out the answer to some of these questions. Besides LRO, which is the spacecraft that's orbiting the moon, I'm also part of a team that's working to build another robot called Viper, which would look something like this. It's going to go to some of those cold, shadowy places near the south pole of the moon to try and tell us more about what water on the moon looks like when you see it up close from the ground. So this is a picture of what Viper might look like when it leaves for the moon in about 2 years from now. And so that's me, that's what I do. This is my last slide. I thought I'd leave you with a photo of me when I was in elementary school, and I've spoken for way longer than the 5 minutes I promised I would speak for. But here I am when I was in elementary school. So this is me. This was back when when I could pull off orange pants. Haven't worn orange pants in a long time. But here I am. So back then, I certainly didn't know that I wanted to be a planetary scientist, but I still liked a lot of the things that I like about my job right now. So I like reading, I liked writing and telling stories and learning about nature. And so looking back, I think one of the reasons I became a planetary scientist is because, and one of the reasons I love it is because it lets me do a lot of those things. You're always learning something new, and I do a fair amount of reading and writing and telling stories like I'm doing right now. So that's me, and I will stop sharing my screen, and hopefully we have lots of questions.
We've got 58 questions. So let's
oh my goodness.
Into it. All right. Our first question. Thank you so much. That was awesome. Those videos were super cool. Amazing.
Yeah, and they're all on YouTube. So so yeah.
Wonderful. All right. First question from Aria. Why does the moon change color?
That's a great question. That's such a great question. That's a lovely question. Why does the moon change color? And I love that question because it means Aria has been looking up at the moon and observing how it changes appearance as the seasons pass by. So so the main reason the moon changes color is because when we look at the moon from Earth, we're looking through the Earth's atmosphere. And depending on how much dust there is in our own atmosphere, the moon can look different. The moon might appear to be different colors. So sometimes when you look at the moon and you notice that sometimes it might sort of look like bright and silvery, other times it might look kind of yellow. A lot of those times what's happening is it's not that the color of the moon is changing, but we're looking at the moon through this filter of our atmosphere, and that can cause the moon to appear different colors. Other reasons why the color of the moon can change is when we have lunar eclipses. And I'm going to leave that to Aria to find out what lunar eclipses are, since we have 58 questions. But that's a lovely question though.
Awesome. The next question is from Miss Goldman's class in Pawtucket, Rhode Island. Shout out Rhode Island. Did you know that Rhode Island has the biggest squid fishery on the East Coast?
I did not know that.
I don't know this stuff. Anyway, the non-squid related question is the man on the moon real?
That's another good question. So that wasn't the man on the moon is real. That was what a good question. So the man on the moon. So for folks who are not familiar with the man on the moon, when we talk about the man on the moon, what we're referring to are some of those dark patterns that you see on the surface of the moon. And so so depending on the stories you grew up listening to, some folks call that the man on the moon, some call it the rabbit on the moon, and there are all kinds of stories about what those dark patches are. So those dark patches themselves are real, and so those dark patches are dark volcanic rocks that form from volcanic eruptions on the moon, and so the patches themselves are real, but what you see when you look at them, that depends on you and the stories you tell. So so one story you can tell is that maybe those patches look kind of like a man on the moon. So some people might call that coincidence, but they're all good stories.
Awesome, thank you. The next question is from Andy. How often do meteorites fall to Earth?
Yeah, great question, Andy. How often do meteorites fall to Earth? So a short answer is all the time. So in general, really large meteorites fall to Earth pretty rarely, but smaller ones. So the smaller a meteorite, or the smaller the size of meteorite you're thinking of, the more often they fall to Earth. So there are what we call interplanetary dust particles, which are the very tiniest of meteorites. They really are dust particles. So those are falling into the atmosphere all the time, and some of them burn up in the atmosphere and never reach the Earth. There are larger meteorites, though, that fall to Earth all of the time. And if you keep an eye out on the news, you'll sometimes see the news about how someone has discovered a meteorite. So I think the last one that I heard about was somewhere in the UK, I think somewhere in England. There was a meteorite that landed basically in someone's front yard. So things like that do happen, and but meteorites are hitting the Earth pretty often. The larger ones tend to be rarer, and the smaller ones happen all the time.
Very cool, thank you. Our next question is from Michael. Does the moon have tectonic plates?
Yeah, no, that's a really good question. That was this was sort of one of the first questions that geologists asked when they started studying the moon, because on Earth we have tectonic plates. Does the moon have tectonic plates? So so the answer is no. As far as we can tell, we have a pretty good we have a pretty good idea of this, but so the moon doesn't have tectonic plates like our own. And why doesn't it have tectonic plates? A little bit of a mystery. So we're still trying to figure out why some places have tectonic plates and some don't. But the answer seems to have something to do with the fact that the moon is smaller and drier than Earth. So that might be a reason it doesn't have tectonic plates. But it does have what we sometimes refer to as tectonic features. So for instance, even though the moon doesn't have plates, the moon does have moonquakes. So like earthquakes, but on the moon, so the ground can shake. And sometimes that's because of things settling in the interior of the moon. Sometimes it's because of a large meteorite impact that sort of makes the moon shake. But so the moon does have, and sometimes those earthquakes and things can create wrinkles on the surface that we call tectonic features. So the moon doesn't have tectonic plates, but it does have tectonic features and what you might call tectonic activity.
Very cool, thank you. Our next question, I'm gonna squish two questions together. One, is there evidence of aliens? And the other being, do you think we'll find aliens on Titan? That's from Atwater Steam Elementary.
Really good questions. So aliens on the moon, haven't found them yet, but there might be some life forms on the moon that are alien to the moon, but perhaps not alien to us. So for instance, a little while ago, there was a spacecraft that accidentally crash landed on the moon. And it turns out that that spacecraft, because it wasn't quite as clean as it should have been, there might be some tiny microorganisms on that. There might have been some tiny microorganisms on board that spacecraft that might have landed on the moon. So we might have accidentally sent life forms to the moon. But because the moon doesn't have, air and a magnetic field and a lot of the things that make life on Earth possible, we don't think those life forms would have survived. But there you go. We might have sent aliens from Earth to the moon by mistake. As for life on Titan, so again, we don't have evidence for life as we know it on Titan, but there's also a lot that we don't know about Titan. And so one of the reasons why Zibby Turtle, who you saw, and others want to go and visit Titan is because we think that conditions on some parts of Titan might be similar to conditions that might have led to the formation of life on Earth. And so Titan's a really good place to go to study some of the chemical reactions that might have caused life to arise on Earth. So as far as we know, we are the only place in the solar system where there is life as we know it, but scientists are certainly still looking.
Very cool. Thank you. Our next question is from Monica Krangle's class in Philadelphia. We are also in Philadelphia. Skype of Scientists in Philadelphia. What would happen if we did not have the moon?
What would happen if we did not have the moon? I hope you haven't been watching that movie about the moon falling to Earth. But yeah, no, that's a really good question though. So if we didn't have a moon, things would certainly be different. The night sky would certainly look very different. We'd miss having it around. But I think perhaps the biggest change you might see if we didn't have the moon is that we wouldn't have ocean tides on Earth. So those are one of the most visible ways in which the moon affects us in our lives on Earth. As the moon orbits the Earth, it pulls at the land and the sea. But when the moon pulls at the sea, it can cause tides. And there one of the ideas that people have suggested in the past is that maybe you needed tides on the ocean to lead to the formation of life on Earth. Maybe you needed tides so that life forms that were born in the oceans could make it to land and eventually turn into us. So tides can be really important to all kinds of ecosystems. So I think that might be the biggest change that you might see if we didn't have a moon.
Awesome, thank you. The next question is, if that water that's on the moon thawed, could we drink it?
Another really good question. So the short answer is we're not sure. And the reason we're not, there's a couple of reasons why this is an interesting question. So one thing to think about is that if the water on the moon thawed, it would be really hard to stop it escaping to space because the moon is small enough and its atmosphere is so thin that if you heated up the ice even a little bit, it would be really hard to stop all of that water just going off into space. But let's say we collected it. Could we drink it? We'd have to do a little bit of work to figure that out, because one of the things that we're not entirely sure is what else is there in the water. And based on spacecraft observations, we have some hints that there might be some things in the water, like some things along with the water, like mercury or hydrogen sulfide, which you probably don't want to drink. If we could figure out a way to filter out those things, then perhaps we could have a little glass of moon water.
Awesome, thank you. Okay. A lot of questions have asked, like, do you get to go to the moon as part of your job as a moon scientist?
Oh yeah, that's a really good question. So personally, no. There are some. I do have colleagues who either are or really want to be astronauts and go to the moon. Me personally, you know, I spend most of my time here on Earth in front of my computer. And yeah, you know, I think mostly because I kind of like it here. So you know, so like, I think is it Elmo who has a song about why he wouldn't want to live on the moon? One of the Sesame Street gang does, but yeah, I prefer to stay here. But some planetary scientists are really interested in going to the moon, and some of them might get a chance to do that.
Awesome. Yeah, I also really like it right here. I don't want to go to space. It makes me nervous. The next question is from Mrs. Osborne's class. Why does the moon look like it changes shapes?
Ah, great question. And you see, I have my calendar of what the shape of the moon is like behind me. So the moon looks like it changes shape because when you look at the moon, so the moon is always there. So the whole moon is always there, but it changes shape because depending on which parts of it are lit up. So if you imagine the moon is like a ball in the sky, generally the parts of the moon that are in sunlight, we see as sort of bright and silvery, and the parts of the moon that are in the darkness, or when it's nighttime on those parts of the moon, we see them as dark. And so depending on where the sun is and how sunlight catches the moon, it might appear to be different shapes. And the best way to figure this out is to act it out with like a basketball and a torch. But the short answer is, you know, it depends on where the sunlight's coming from and which parts of the moon are lit up.
Very cool. Thank you. The next question is from Samantha. Actually, Bella would like to know, how do people float on the moon?
How do people float on the moon? So the good news is, Bella, you wouldn't float completely away because the moon has enough gravity that, you know, so if you were to jump on the moon, you'd probably go a little higher and a little further than you would on Earth, but you would land back. You wouldn't float away entirely. But the reason that you'd go further is because the moon is smaller than Earth, and so it doesn't hold things to it as tightly. Or, you know, another way to think of it is that the moon has a lower gravity than Earth, but basically the moon, because it's smaller, it doesn't hold things to it quite as tightly, and so that's why you can why things are floatier on the moon than on Earth, even if they don't all float away altogether.
Awesome, thanks. The next question is from Alice from Atwater Steam Elementary. Did the collision, so this collision being the collision that led to the stuff floating around that then became the moon, did that happen before or after the dinosaurs?
This was long before the dinosaurs. So the dinosaurs lived until a few 100 million years ago. The moon forming collision, now that happened, we think 4.5 billion years ago. So this was long before the dinosaurs. And in fact, even the volcanoes on the moon, those happened before the dinosaurs as well. So those happened later, but still before the dinosaurs, when life was sort of still swimming around in the oceans on Earth, and little single-celled organisms were still taking shape.
Awesome. Next question is from Jesse. How long does it take for information to get from these instruments that are monitoring the moon back to us?
Oh, that's a wonderful question. I think, and you might want to double check the answer. I think the answer is something like 3 minutes. So information travels as fast as fast as light travels, but then, you know, sometimes it takes a little while for that to get sent around to where it needs to go on Earth. But I think that the time delay is something like 3 minutes. That might be wrong, so you should check me on that. But I think it's something like 3 minutes.
But certainly not 3 seconds and not 3 hours. Something like a minute, the minute scale kind of question.
Mm-hmm.
Okay. Okay, so it's 1:45. We still have so many questions left, but we try to keep these to 45 minutes. So thank you so much for everything. I think what we've learned today from my end is that I need to have more space sessions for sure, because there's so much space curiosity. If we didn't get to your question today, everybody know that you can sign up on skypeascientist.com to have your own space scientist come to your classroom and just answer the questions that are in your classroom. You can do that at skypeascientist.com, click get involved, and then request a scientist. We have plenty of scientists for you to choose from. We always ask everybody the same two questions at the end of every session. The first question is, if you had everyone's attention in the whole world and you could tell them anything about your area of expertise, what would it be?
Ooh, that's a good question. I think what I would say is that perhaps the most important thing that we've learned from studying the planets and the moon and other worlds is what a special world we have right here. And so, so I think that the big lesson that planetary science teaches us is that planets like Earth are rare and special, and we should take good care of them. And the same goes for all of the other worlds. I think that the most wonderful thing is that each of these places has their own different environment, and they're all special in their own ways. And we should appreciate that and take care of all of these special worlds out there.
Amazing. Thank you. The next question is, you still have everyone's attention in the world, and you can tell them one thing about literally anything. It can be as important and significant or silly and just important to you as you'd like. What do you tell them?
Yeah, I'm gonna go with something a little philosophical maybe, but I think the other thing, I think one really important thing to remember is that science is always done by people, and the same goes for everything else, but since I'm a scientist, I will tell you that science is always done by people. And I think one of the most important parts of being a scientist is taking care of the people around you and making sure that that they're in a place where they're comfortable enough to do all of the science in all of the ways that they find interesting, and then they can come and tell you about it. So I think one thing I would say is that the most important thing about science or anything else is really always the people. So take care of yourselves and take care of the people around you, and that's sort of something that's the prerequisite for all good and interesting science.
Absolutely. Awesome. Thank you so much. Is there anything else that you'd like to plug or share with us before we say goodbye?
I think the only thing that I would say is I really do love questions, and I will put my email in the chat. And so, if you want to send me questions over email, I'm happy to try and answer them. And I love Skype a Scientist, and so so if you put in a request for a space scientist, who knows, you might end up with me, whether that's good or bad. I won't say, but I'm going to put my email in the chat right now, so you might hear me typing. But feel free to reach out.
Wonderful. Amazing. Thank you so much. Everybody, the next time we are gathering will be Monday, March 7th. So that's a week from today. We're going to be talking all about kelp. Let me get that link for everybody in the chat. We're talking about kelp with Renee Francoli. It's going to be really cool because kelp is wild and awesome. Hope to see you then. Kay, thank you for interpreting. Thank you for sharing about the moon, Parvathy. This was so cool. So cool. And thank you all for coming. Thank you for being with us today. If you want to share this with other teachers, classrooms, students, etc., it'll be on youtube.com/skypeascientist, as all of our sessions always are posted thereafter. All right. Have a wonderful rest of your week, everybody. We'll see you back here next week.
Thanks, everyone. Take care.
Bye.